Good morning, everyone. My name is Bandana Kumari. I am Assistant Professor in Department of Information Technology at IIMT College of Engineering, Greater Noida. Today, I am going to deliver lecture on memory management. Memory management is a function of operating system. It is a very important topic of operating system. So these are the outline of today's lecture. First one is background. I will discuss about swapping. Then I will describe contiguous memory allocations. After that, I will discuss dynamic storage allocation problem. At last, I will discuss about fragmentation. First, I will discuss about background concept of memory management. So we know that a program is stored in secondary memory, secondary storage devices. So if we want and whenever we want to execute any program, so first of all, program must be brought from disk into main memory and placed within a process for it to be run. Cache lies between main memory and CPU registers. Register access in one CPU clock. Main memory and register are only storage CPU can access directly. Protection of memory required to ensure correct operations. Now I would like to explain base and limit register. Base and limit register are hardware registers used in computer systems to enable memory protection and provide a virtual address space for programs. The use of base and limit registers is a simple and effective way to provide memory protection and prevent programs from accessing unauthorized memory. They are commonly used in modern operating systems and virtual machines to provide a secure and isolated execution environment for programs. For example, in this diagram, the base register value is 30040 and limit register is 12900. Base register contains a starting address while limit defines the range of address. Here the address generated by CPU is referred as logical address. This logical address is compared with base. If logical address is greater than equal to base register value, then the logical address will be compared with the base plus limit value. If it is less than, it will be mapped to the main memory. Otherwise, it will trap to operating system or generate addressing error. What is logical address space and physical address space? Logical address that is generated by the CPU, also referred to as virtual address, and physical address that is address seen by the memory unit. Logical address space is the set of all logical address generated by a program, and physical address space is the set of all physical address generated by a program. Memory management unit. A memory management unit is a hardware component of a computer system that manages the translation of virtual memory addresses to physical memory address. The memory management unit is responsible for providing the necessary protection and memory management services required by modern operating systems. To start, consider simple scheme where the value in the relocation register is added to every address generated by a user process at the time it is sent to memory. In this diagram, CPU generate logical address 346 and logical address value added to the relocation register and map to the main memory. What is dynamic loading? Dynamic loading is a technique used in computer programming to load a library or module in a program during its runtime instead of being statically linked during compilation. Dynamic loading is often used in operating system, web browser, and other software applications where there is a large amount of code that may not be needed all at once. Routine is not loaded until it is called. Battery memory space utilization. Unused routine is never loaded. All routines kept on disk in relocatable load format, useful when large amount of code are needed to handle infrequently occurring cases. No special support from the operating system is required. So now I will discuss about swapping. What is swapping? Swapping is the process by which process is loaded and unloaded by the main memory to secondary memory and secondary memory to the and to main memory. There are two types of swapping: rollout and rolling. Rollout in rollout process roll out from main memory to secondary memory. If we want to execute any program in main memory, in that case process bring from main memory and loaded to the main memory from secondary memory. So in this diagram we can see that process P1 and process P2 that is stored in secondary storage. So we want to execute process P2. So first of all we will swap in process P2 to the main memory, and we can see that process P1 that is swapped out from main memory to the secondary memory because we have limited memory space in main memory. So we will swap out process P1 to the secondary storage. Contiguous allocations. Contiguous allocation is a method used in computer system to allocate memory or disk space to a program or file. Main memory usually divided into two partitions: resident operating system usually held in low memory, user process that held in high memory, each process contained in a single contiguous section of memory. Multiple partition allocations divide memory into several fixed size partitions. Each partition stores one process. Degree of multiprogramming limited by number of partitions. If a partition is free, load process from job queue. Relocation register is also called base registers. Relocation register contains value of smallest physical address. Limit register contains range of logical address. Each logical address must be less than the limit register. Memory management unit maps logical address dynamically. In this diagram, CPU generate logical address. So first we will check logical address value is less than limit register. If yes, then we will add logical address value to the relocation register and map to the main memory. If logical address greater than limit register, in that case there is addressing error in the operating system. Multiple partition allocations, variable partition scheme, whole, a block of available memory, holes of various sizes are scattered throughout memory, keeps a table of free memory. When a process arrives, it is allocated memory from a hole large enough to accommodate it. Process exiting frees its partition, adjacent free partitions combined. Operating system maintains information about allocated partitions, free partitions. In this diagram, multiple partition allocation to the process. Dynamic storage allocation problem. So in this topic we will explain how to allocate the holes from the free hole list to the process of size n, and this problem is known as dynamic storage allocation problem, and there are three strategies or algorithm to solve this problem. So first algorithm is best first fit. In this case, allocate the first hole that is big enough, and second one is best fit, allocate the smallest hole that is big enough and must search entire list, and last one is worst fit, allocate the largest hole and must also search entire list. So I would like to explain about dynamic storage allocation problem for examples. So I have an example. Consider six memory partitions of size 200 KB, 400 KB, 600 KB, 500 KB, 300 KB, and 250 KB, and these partitions needed to be allocated to four process of sizes 357 KB, 210 KB, 468 kb and 491 kb in that order. So in this example we will discuss about how to allocate process to the memory. So first fit algorithm, best fit algorithm, and worst fit algorithm. In this diagram, we can see that memory is divided in different sizes, having size 200, 400, 600, 500, and 300 and 250 kb. And we have four process P1 having size 357 kb, process P2 having size 210 kb, process P3 having size 468 kb, and last process P1 having size 491 kb. So now we'll explain first fit. So process P1 having size 357 kb. So we must check first sections of memory having size 200 kb, that is not big enough to accommodate process P1. So I will check in second hole that having size 400 kb, that is big enough to accommodate P1. So in this area and this whole allocate to the process P1. Step second, process P2 having size 210 kb. So we will check in first hole that that size 200 kb, that is less than process size. So we will check next hole having size 600 kb, that is big enough to accommodate process P2. So this hole allocate to the process P2. Step 3, process P3 having size 468 kb. So we will check 200 kb. 200 kb is less than to the from process size. So we will check next hole that is free 500 kb, that is big enough to accommodate P3. So in this that hole allocate to the process P3, and process P4 having size 491 kb, and there is no free space to accommodate that process. So these are the example of first fit. Now I would like to explain best fit. Uh, so P1 having size 357 kb. So we will check entire system where free space, smallest free space to accommodate that process. So 400 kb is a smallest size to accommodate process P1. So that whole allocate to the process P1. When uh, P2 process P2 having size 210 kb. So in this case we will check entire system. So we can see that 250 kb, that is big enough, and that is smallest one to allocate process P2. uh, when process P3 reached, in that case, having P3 size 468 kb. So in this diagram, we can see that 500 kb is smallest smallest size to accommodate and allocate to the process P3. And when P4 process P4 having size 491 kb, so first of all we will search entire system where is the smallest value to accommodate and allocate to the process. So 600 kb is the smallest one that allocate to the process P4. So worst fit is a algorithm of memory allocations. So in that case, process P1 having size 357 kb, so we must check largest hole of main memory. So 600, we can see that 600 kb is the largest hole. So this hole provide to the process P1. And next step, process P2 having size 210 kb 210 kb, so we will check largest size of the main memory. 500 kb is the largest size of main memory, so that whole allocate to the process P2. Process P3 and process P4 cannot be allocated to the memory. This is because the no partitions of size greater than or equal to the size of process P3 and process P4. Fragmentation is the unwanted problem of the memory management. In that case, process is loaded and unloaded from the memory, and the memory is broken into little pieces. There is two types of fragmentation: external fragmentation and internal fragmentation. In external fragmentation, there is a big enough memory space to satisfy any request, but it is not contiguous. And reduce external fragmentation by compactions, shuffle memory space, memory contains to place all free memory together in one larger block. Compaction is possible only if relocation is dynamic and is done at execution time. Internal fragmentation, allocated memory may be slightly larger than request memory, and this size difference is memory internal to a partition but not being used. Reduce external fragmentation by compaction, shuffle memory contents to place all free memory together in one larger block. Compaction is possible only if relocation is dynamic and is done at execution time. Internal fragmentation, allocated memory may be slightly larger than request memory. This size difference is memory internal to a partition but not being used. So we can see that in this diagram we have 40 kb, 10 kb, 5 kb, total 55 kb free memory space to accommodate any process, but that is not contiguous. These are the differences of today's lectures. Thank you so much.